All right, so 6.7 day 2. This is the last lesson that we did. All right, so this is it. We have 2 days to review this week. That's on Monday. Okay, that's what we're looking at. So make sure, don't wait until Sunday night. You're studying in. Okay, study this week. Do it every day. Make sure that we're ready to go for Monday. All right, so we are talking about recursive rules again. We talked about those yesterday. But today we're also bringing back the explicit rules. Okay, so as a reminder, our geometric explicit rule. We talked about it before the midterm. Geometric explicit rule, if we're finding the nth term, a sub n was equal to a sub 1 times r to the n minus 1 power. Okay, that was our geometric explicit rule, where we had our first term, we had our common ratio, and then to the n minus 1 power. So we are going to be referring to that again today. We're going to be creating rules that look like that today and looking at rules that look like that today. Okay, that's the easier of the two. The other one is the arithmetic. So we're going to talk about that one here. So the arithmetic explicit rule. Now we did this one a while ago. Right, we did this 4.6. So it's been a while. If you recall, and this isn't the one that we're going to use today, but if you recall, we started this conversation by looking at this long format, and then we got a shortcut out of it. Okay, but where we had the first term, we had the common difference, and then we simplified it. What we ended up with was something in y equals mx plus b. So we end up with something like this, where we had a sub n, let's say we had a sub n is equal to 4n minus 3. All right, we ended up looking something like this for our explicit arithmetic rule, where we could plug in a 20 and that would give us the 20th term. Right, we could plug in a 30, we spend 30th term. What this was, just as a reminder, where we got these two numbers from for our shortcut. This number right here, this was our common difference. So that's what we are adding every time in our arithmetic sequence. So the slope was our common difference. And then this number back here, if you recall, is what we refer to as the zero term. If we went backwards from the first term to get that zero term, that's that number, that intercept. It's been a while, okay, but we are dealing with this today. So we have to remember common difference, zero term. Okay, because what we're going to see to start here is they're going to give us a recursive rule, just like we saw yesterday. But we're going to take that recursive rule and we're going to create the explicit one. We're going to talk about how to do that. So they give us the recursive like we saw yesterday. We're going to take that. We want to create something that looks like this. We want to create that y equals mx plus b. Now we know that our slope needs to be our common difference. Looking at that recursive rule, what is our common difference here? Cooper? Yeah, the negative 10. Right? This was always our common difference. It's what we're doing every time. So when we go to create our explicit rule, a sub n is equal to negative 10n. So this number is going to go here because that's our common difference. Okay, that's the easy part. Get that common difference. It's in our recursive. We put it as a slope for our explicit. But then we need to figure out what that zero term is. We got to figure out what are we going to add or subtract over here. I'm just talking person next to you. What do you think that zero term would be here?
I went to 35.
So the debate here is it 15 or is it 35? That's the question. 15, because we know it's 10 away, right? So raise your hand and tell me, is it 15 or is it 35? And why do we think that? Ashley?
35.
Why?
Because you're going backwards, so it's the opposite.
Yeah, our common difference is -10. That's when we're going forward. And we know 25 is the first term. So as I keep going forward, I'm going to be subtracting 10. So my second term is going to be 15. Right? My zero term, I got to go the other way. So instead of subtracting 10, I am adding 10. So this is going to be plus 35 here. Okay, so how we get that is we have to take that common difference, take the opposite of it, and combine it to my first term. I got to go backward. So instead of minusing 10, I am adding 10 to it to get that 35. That right there, that idea of how to get that zero term, that's probably the trickiest part of all of this today. Is understanding and remembering, not just knowing it, right? We can listen to it right now and say, yeah, that makes sense. But remembering to do that. Okay. So however you want to represent that in your notes, I would write something down about it. How did we get that 35? Okay. So right now, write something down. How did we get that 35? All right, here's another one try. Okay, here's our recursive, create that explicit rule. Let me check for somebody, see if you have the same thing here. All right, raise your hand and tell me what equation do we have here? Lloyd?
X of n equals 6n minus 26.
There you go. 6n minus 26. As we know we're adding 6 going forward, so we subtract 6 to go backward to find that negative 26 as the zero. Any questions on this version of it? All right, now we got to do geometric. That geometric is easier. Pretty straightforward, actually. Because if you look at our geometric explicit rule, there are two things that we need. We need the first term, and we need the common ratio. In our recursive rule, they give us the first term and the common ratio. And they're even in the right order for us. So all we have to do is take those two numbers, 19.6, negative 0.5, to the n minus 1 power. Okay, it's right there for us. It's in the right order. We just gotta make sure we do the little things like the n minus 1 needs to be that exponent now. It's not a subscript anymore, it's an exponent. And the negative 0.5, anytime it's a negative, it has to be in parentheses. Me personally, I would just always put that common ratio in parentheses. It's not gonna hurt anything. But you definitely have to have it there if it's a negative. Okay, gotta have that R in parentheses when it's a negative. That one's pretty straightforward. That's just putting those two numbers exactly where they need to be. They're in the right order, right there for you. Let's just make sure before we move on. Let's say we have a sub 1 is equal to 2/5. We got a sub n is equal to 17 a to the n minus 1 power. Write that explicit rule, please. And then tell the person next to you, what do you got? Okay, there we go. A sub n is equal to 2/5 parentheses. I put parentheses, you don't have to have parentheses there, but 17 to the n minus 1. Questions on going from recursive to explicit? Okay. So then the other thing that we have to do is go the other way. So they're going to give us the explicit, and we need to come up with the recursive. So talk to somebody, work it through. Let's see what we can do. Creating recursive here. Make sure whatever you have down, you have two parts to each one. Remember, we need a sub 1 and we need what's happening to it for each one. Another 30 seconds to talk about it. If you haven't talked to somebody yet, please do so. Make sure we're doing both. So let's start with A. What do we have for A here? 7?
I said a sub 1 equals 1 and that like space thing.
Yep.
A sub n equals a sub n minus 1 plus 3.
Oh, not plus 3. Cooper, what goes there?
I think it,
Remember, this is our common difference. The slope is the common difference there. Okay, that plus 3, that's our 0 term. The -2, the -2, that's our common difference. That's what's going in our recursive. Okay. Somebody other than Denver, tell me, how do we get that 1 as being our first term? How do we know 1 is our first term? Logan?
and it's like 3 is a 0 term. Then we get the first, we have -2.
Yeah, we're gonna keep going, right? We're gonna go forward that -2. Now, also remember that this is an explicit rule, meaning that I can, whatever term I'm looking for, I can plug that in for n. So if I want to know my first term, I can just plug a 1 in for n, and that's gonna give it to me, right? Every single time. If I want that first term, I plug a 1 in, and multiplying by 1 doesn't change that number at all. So anytime I'm looking for that first term, all I'm doing is I'm ignoring that n and I'm combining those two numbers. -2 plus 3 is 1. My first term is 1. Okay, every single time. Because n is 1, it's first term. Okay, and then we've got that. Good, questions on A? That's the harder of the two. Okay, and then what do we have for B? Here, what do we have for B? Brian?
I got a sub 1 equals -3.
Okay.
A sub n equals 2a sub n minus 1.
There you go. Good. Remember, that's our first term, that's our common ratio. Perfect. Okay. Questions on that? Okay. So we've got another thing that we got to talk about here. Right. First of all, any questions, because we're moving away from arithmetic and geometric. Any questions on that stuff that we've done so far? Okay, so now we are getting into, like I said, not geometric and not arithmetic. So there's still going to be sequences. It's still going to be a pattern. But it's not going to be arithmetic, it's not going to be geometric. We're not multiplying or adding by the same thing every time. Okay, this sequence that I'm going to show you is probably the most famous sequence out there. Okay, mathematical, scientific wise. Okay, here's our sequence. Anybody recognize the sequence? Know anything about it? Cooper?
So what you're adding by every single time is going up by 1 every single time. So first you add by 0, then you add by 1, then you add by 2, you add by 3.
But here I added 0, I added 1, I added 1, I added 2, I added 3. And on the next one, I'm going to add 5. Braden?
I don't know how to explain it, but it's like, it's 2 and then you add it to 2 numbers before it or something, like.
Next one, thing in the sequence is
So what would the next term here be? 13. Okay. Sam, what do you got?
So what I was thinking is like, the reason why it goes from 1 to 2 and then 2 to 3 is because you're adding the 1 from the start and then you're adding the next one after that.
Yeah, we're adding the 2 terms to get the next one. So these added together get me here. These added together get me here, and so on. Right? So the next term would be 13. Oh, the next one would be. And then. It's like you skipped that 13.
I looked at the 8.
Yeah. Yeah, so we're not adding by the same thing every time. It's not arithmetic, right? Not geometric, we're not multiplying by anything. It has a pattern. So this pattern is called the Fibonacci sequence. Named after a guy named Fibonacci. Yeah. Yeah. That's why it's called that. No, it's crazy. So this is the Fibonacci sequence, very famous sequence. And what we're going to do with it is we're going to create a recursive rule for this. We cannot create an explicit rule. There's no way for us to create a rule where we can plug in 17 in for n and find the 17th term. We don't know how to do that, okay? But we can create a recursive rule. So our recursive rule, right, if I want to find a term, any term, how do I do that? How do I find any of these terms? Like if I'm talking about the 13, what did I do to find that 13, get that number 13? What's happening here? Zach,
You add the two numbers before it.
they add the two numbers before, okay? So to find this term, to find the nth term, I need to add the two numbers before. How can I represent the two numbers before a sub n? Cooper?
A sub n minus 1 plus a sub n minus 2.
Yeah, so remember, a sub n minus 1 represents the number before the term we're looking at. And so the one before that is going to be a sub n minus 2. Because that's saying if this is a sub n, right, the nth term, whatever number term that is, this is one less than that, this is one less than that. So if I'm looking for that a sub n or a sub n, I'm going to add up those two previous. I'm going to add up a sub n minus 2 and a sub n minus 1. I'm going to add those together. Okay. This is our recursive rule. To get any term, we're going to add the two before it. You're going to see stuff tonight in the homework that looks like this. It's not going to be this exact sequence. You might have to subtract the two terms before it. You might have to do something different, right? But that's the general idea here, is we are taking and realizing that we can label the terms before something as n minus 1 and n minus 2. Now, this is not enough for a recursive rule, though. What else has to be there for a recursive rule? Yeah, we got to know where we're starting, right? So a sub 1 is 1. Okay, we got that. But I want you to look at this and I want you to think critically here. Let's pretend that we don't know our sequence. All right, the whole point of our recursive is that we can regenerate or we can create our sequence. If I just know this, is that going to be enough for me to create the Fibonacci sequence? I know that I'm starting at 1. But that's it. I don't know what that second term is. Because to find the second term, I would have to add this plus this. I don't know what this is. This doesn't exist. Right? Sam? Yeah, I got to know the first two numbers in my recursive rule. Because now that I know the first two numbers, now I can follow the pattern. Now, all right, if I'm starting with 1 and 1, now I can start and go from there. Yeah.
Like find it by like with just one by just looking at what that number was.
Not necessarily, because you don't know, because we could have the same idea, but have our sequence start at 6. Right? And if our sequence starts at 6, I can't continue with this rule until I know what that second one is. There's no way to know unless I know what the first two terms are. So on something like this, on these weird ones, you're going to have to tell the first two terms. And they're going to have boxes for you on big ideas. They're going to ask you what a sub 1 and a sub 2 are. Because they know we need those first two listed. Okay. So you're going to see some weird stuff. This is at the end of the homework tonight, where we have to create those recursive rules for those other types of sequences. Okay.
So when we solve that, we have to like keep writing until that term.
If we wanted to find a specific term, you're saying?
Yeah, so like if I was looking for a sub 17.
You would have to just keep going until we get there. Yeah, there's no equation that'll get us there. Yeah. All right, any questions? All right, that's it.